All right, moving on in this section, we're going to move from solving just absolute value equations to solving absolute value inequalities. So when I say inequalities, I mean you'll see symbols like greater than or less than, greater than or equal to, less than or equal to. So suppose we want to solve the inequality, the absolute value of x is greater than 3. So really, we want to know that when the graph of this y equals absolute value of x, which you see here, is above the graph of the line y equals 3. So I'm going to go ahead and graph the line y equals 3, which we've done a couple of times now. And I want to know where my absolute value function, holy cow, let me make that a better line. Good enough. I want to know where my absolute value function is above that line y equals 3. And I see that it corresponds to the following x values, positive 3 and negative 3. But I can't just say that x equals positive 3 and x equals negative 3. I have to look at all of the x values that my highlighted section corresponds to. So if I look at my first highlighted section right here, if I trace that down to my x-axis, that also goes over all of the x values that are greater than positive 3. Additionally, if I look at my second highlighted section, on the other side of the graph, that goes over the x values that are smaller than negative 3. So I have two different pieces of my solution. X is greater than 3 and x is less than negative 3. Now, that was all dependent on this symbol in between and the way the graph was flipped. So I can't just make the assumption that whenever I see this greater than symbol, one of my solutions is going to be greater than and one of them is going to be less than, because we could have had a situation where I was looking underneath that line y equals 3, and I would have written a solution that said it was all the x values in between positive 3 and negative 3. So when we look at just solving equations, we're going to solve what's called the related equation, meaning we're going to pretend like this inequality symbol in the middle is actually an equal sign, and then we're going to test solutions on a number line to see whether or not those solutions solve our inequality. So for example, I'm going to solve the related equation, meaning I'm going to remember that this is actually an inequality, but I'm going to start by just solving 2x minus 5 equals 3. We'll notice this is not an absolute value equation, this is just a linear equation, but it serves as a good example. If I were to solve this linear equation, I would start by adding 5 and getting 2x equals 8, divide by 2, and get x equals 4. But now remember, I'm not actually solving an equation, I'm solving an inequality. So what this means is on a number line, I'm going to put the number 4, but I'm going to test values on either side of 4. So I might test the number 5, which is bigger than 4, and the number 3, which is smaller than 4. So if I go back to my original inequality, I'll start by plugging in the number 3 for this x, and I'll say, is 2 times 3 minus 5 greater than 3? That's what I'm asking myself. Well, I know that 2 times 3 is 6, minus 5 is 1. So is 1 greater than 3? Nope. So I know that this side of the 4, anything less than 4 is not going to work. I could have plugged in the number 2 or the number 1 or 0. None of those numbers would have satisfied the original inequality. So now I'm going to try this number 5. If I plug in 5 now, 2 times 5 minus 5, is that greater than 3? Well, I know that 2 times 5 is 10, minus 5 is 5, and I'm asking, is 5 bigger than 3? Yes, it is, which also means that the number 6, the number 7, the number 8, the number 4.2, all of those numbers would have satisfied the original inequality, meaning that my x values are anything greater than 4. So now let's extend that idea to an absolute value equation. If I start by just solving this related equation, again, I'm going to pretend like this thing is an equal sign. Give myself some space so that I know what goes with this problem. I'm going to start by subtracting 1. I'll get 2 times the absolute value of x minus 3 is less than or equal, oops, just kidding, I want to solve the related equation. I just want to put an equal sign there, is equal to 6. I'll divide by 2. and get the absolute value of x minus 3 equals 3. Remembering how we solve an absolute value equation, at this point, I can make my two separate equations. X minus 3 equals positive 3, and x minus 3 equals negative 3. I'll add 3 on each side to each equation, and I get x equals 6 and x equals 0. So now, again, I don't know if these values that satisfy the original inequality are in between 0 and 6, if they're bigger than 6 and less than 0, so I have to test my solution on a number line. So 0 is smaller than 6, so I'm going to put that to the left. And then I'll pick numbers in each of these three different intervals, and I'll test them. So a number smaller than 0, we'll call negative 1. A number in between 0 and 6, let's call that 3. And then a number bigger than 6, maybe we'll say 7. Okay, so now my job is to go back to this original inequality and test the numbers negative 1, 3, and 7. So let's start with negative 1. 2 times the absolute value of, instead of x, negative 1 minus 3, close your absolute value, plus 1. I'm asking, is that less than or equal to 7? So with order of operations, I'm just going to look at this left side, and I'm just going to evaluate. I'm not trying to solve anything here. So when I evaluate, I'll start inside the absolute value. I know that negative 1 minus 3 is negative 4. I still have the 2 on the outside, I still have the plus 1, and I'm still asking myself if that's less than or equal to 7. I'll still work on my absolute value. I know the absolute value of negative 4 is positive 4. The distance away from 0 of negative 4 is positive 4 units. Still working with order of operations, now I know that 2 times 4 is 8, plus 1 is 9, and I'm asking myself, is 9 less than or equal to 7? No, it is not. So for this first section of my number line, none of the values less than 0 would have satisfied the original equation. Now let's plug in the number 3. Into my original, 2 times the absolute value of 3 minus 3, plus 1, is that less than or equal to 7? Just like how we did in the first one, start inside your absolute value. 3 minus 3 is 0. Still have your times 2 and your plus 1. I know the absolute value of 0 is just 0. 2 times 0 plus 1, well, 2 times 0 is 0, plus 1 is 1. And is 1 less than or equal to 7? Yes, 1 is less than 7, meaning that any number in between 0 and 6 would have worked. So again, I could have picked the number 2, I could have picked the number 1, 4, 5, any decimals in between those. All of these numbers would have worked if I plugged it in. We still have one more interval to test, so I'm going to plug in the number 7. 2 times the absolute value of 7 minus 3, plus 1 is less than or equal to 7. 7 minus 3 is 4. The absolute value of positive 4 is still 4. And then 2 times 4 is 8, plus 1 is 9. And again, 9 is not less than or equal to 7. So none of the numbers bigger than 6 would have worked either. So really, my only solution set happened in between 0 and 6. So any x value that I would have plugged in would have worked, which means my solution then is any x value that's greater than or equal to 0, or any x value that's less than or equal to 6. Let's try one more together. This time, I'll start by subtracting. I'm going to make this an equal sign, solve just the related equation. Start by subtracting 3, and we get negative absolute value of x plus 1 is equal to 4 minus 3 is 1. To get rid of that negative on the outside, we'll divide both sides by negative 1 and get the absolute value of x plus 1 equals negative 1. So we run into a similar situation like we had in some of our previous examples, where we have an absolute value equation equal to a negative number. But before we just jump to conclusions on this, we have to remember that we're not actually solving an equation. We're solving an inequality. So there still could be something that works here. So I'm going to visualize what the graph of this would look like. If I have my graph, I'm just going to make a quick sketch. I know that it's a reflection, shifted to the right one, and up 3. Or I'm sorry, to the left one and up 3. So to the left one, up 3, and it's a reflection, so it's going to look something like that. But then I also have this line y equals 4, which is up at the 4, and a line straight across. So notice how these two graphs are never actually going to touch each other. They're never going to intersect. So when we say, when is this absolute value function greater than the number 4? Well, if we look at our graph, this absolute value function is never going to be above that line of y equals 4. So in this case, there really is no solution.